Hi, this is Austin here to talk about the final sprint and just go through everything. So I'll start with the main engine class since that's the first thing on the checklist. The big four now, mostly just delete and empty because they don't really need to do anything. Implemented as a singleton, of course. The initialize, load, update, draw, and unload, as along with the user-defined functions. And here I tried to standardize the names a bit to more accurately reflect what they actually mean. So set window, WH, window name, window width height, all that. As well as, actually, yeah, most of these were already one-liners and they still are. And they just called the instance to call the functions. Gave this a better name to differentiate it from just the regular run. And then most of these are just very simple. Oh yes, the reason I load these two specifically outside of load resources is because this one is needed for the visualizer and this one is needed for sprites. So it seemed in case the user didn't load those mechanisms would break. So it made more sense to me to just include them here so that they would have to be included. Update now has the calculate time here, and then draw and unload is all the same. This should be everything that needs to be deleted. And the end function, initialize, load resources. Initialize and end don't really do very much. The resources will show you I'm loading models, loading pixel and non-pixel textures, images and shaders, and submitting base scene as the base scene. So I'll go ahead and open up all of my managers, my resource managers now. And they do all have attorneys, by the way. You can see that here. The only one that doesn't is the image manager, which doesn't really need one since I'm no longer using, what's the word? Registration. So private load and load pixel. You can see I'm using a map, by the way, because that will be logarithmic with the insert. And I have some if checks to see whether or not whether the key is already in use or not, as well as another check here to say that you tried to find something that's not in there. So again, these could probably be debug message out rather than printf, but that's like a 5-second change. So you can see also that the texture manager is implemented as a singleton, and there's the map. All these functions private delete, by the way, just to be safe. Shader manager is pretty much the same with a load, get, and delete. I'll show it off just to be safe. And then model manager is also pretty much the same. And here's the image manager. Again, private delete. And here is the actual stuff for that. So I'm opening now all of the time-related stuff. First of all, the freeze time, which is just the same code that you gave us, but here it is in case you feel the need to see it again for some reason. And the time manager itself, which is what I made, implemented as a singleton. Here is where frame time and total time is set. No longer as an ugly two-liner, but as doing it this style, which should be okay to include in the header. And then just some get sets, and then my calculate and delete, which are here. And yeah, so this is using the freeze time, so it no longer uses the engine attorney get time, that is here. Using an attorney, by the way, just to be clear. So it's not getting it straight from the engine, it's getting it through an attorney. I'll go ahead and open up everything scene related now. And start from the scene manager. So implemented as a singleton, as you can see, has the big four. Again, doing the the variable setting here, delete, delete, empty. And the reason Scene Manager is empty is because everything it needs to do is done in delete. It no longer deletes the current scene in delete. That is done separately as part of the I think it's the unload resources function in osengine.cpp. I realized I did not draw attention to that, so yeah, there it is. I just go through the Scene Manager and end the current scene there. So I still do delete it in the Scene Manager, which should be fine, but that's no longer where it ends the scene, which I recall being an issue in code review. So that's should be everything, along with its commands. So it's using those to determine when to change scene. So that's not an if statement. The null scene is just a dummy scene. It doesn't do anything and goes in at the beginning of the game. The registration broker, it just has an add command, and then on a frame-by-frame basis, it will execute all of its commands. So, and it does have the big 4 again. Here are the things to let it do its commands. So the actual scene class, align 16. So you can see some of my documentation here, because this is one of the classes where the user will actually have access to it, unlike a lot of the ones so far. And to be clear, by the way, I am missing documentation in a couple spots. I'm actually going to try and use a couple hours after I finish recording to add some, to continue adding documentation to some of the stuff I don't have yet. But I wanted to actually get this video up just in case, for whatever reason, I don't finish that in time. So that hopefully should be fine by the time you're actually looking at this, but that's why it hasn't been there so far. This still have some cheat functions to pass through the camera and the orthographic camera, but the scene itself does not have access to those. The function just gets them from the current scene and passes, or gets it from the cam manager and passes it along. So set collision pair, set collision self, and then all my managers, which is why I have so many includes in this one specifically. Okay, so this is actually something I caught just now as I was doing this. I realized that the draw was in the .h when it should be in the .c++. And so does all the draw and then does the visualizer. And when I get to the draw manager, I will show you that it is doing the draw 3D before the draw 2D. Although that should be fairly obvious when I actually run my demo, because the sprites are not working. I mean, they are working properly, and if I was doing that wrong, then they would not be working properly. So I'll go ahead and start the game object show off by starting with the actual game object class. It includes everything that it needs to inherit from. So drawable, updatable, alarmable, inputable, collidable, and then align 16, which is a separate issue entirely. Excuse me, a separate issue entirely. Big 4 again. So more documentation with submit entry and submit exit. You can see that just talk about what those do, and then the get camera function to be used by derived classes of the game object. So again, there's a couple levels of shortcutting here, but it's not inefficient or anything. It just looks a little bad, so for the time being, I thought it was fine to leave it as is. There were more important things to tackle. So I have the state, enter, and exit commands, as well as a pending exit check. Here are the scene entry and exit, which are just empty to be overridden by the user, and then connect and disconnect from scene. So pretty much most of these are going to involve setting the enter and exit commands and then using them when appropriate. Submit entry, submit exit. This is the only special one, because you can see I use the pending exit check to determine whether or not it's already ready to exit, and if it's not, then I'll set it ready to exit and then let it exit. So connect and disconnect, very simple, and then it deletes the commands when it's done. Next, I will look at the drawable. So let's see here. Big 4 again. More documentation with the submit, registration, deregistration, but those I will show the actual code in a minute. the commands, and then the draw and the draw2d, to be clear. And also, since I just forgot to mention it last time, you'll notice that all of these, including the update, have functions to give and set the references to where they are in the drawable manager, or the drawable manager, update manager, etc.'s list. And I will show that off when I actually get to the managers. But anyway, so the drawable, this is all pretty much the same. Now I'll actually go over to the managers for the drawable and updatable. Drawable manager, updatable. So, I have a list, I have the updatables, and then I just put them all on a list, and then I process the elements with the register and deregister. And really all it does is loops through everything and updates them. And you can see here it's using the iterator that is passed along to the updatable object to determine where to get it from, or where to erase, that is, and then here it sets that reference when it's registered. So there it is. Drawable manager does the same thing. A lot of this is going to look pretty much the same. The only real difference is the process elements, where it does a first pass to do all the draws, and a second pass to do all the draw2ds. Okay, so now I'm going to look at the alarm system. Oops. And it's going to start off pretty similar to the other two, where it just has the big four, has its attorney, has registration and deregistration, now with an ID as well as time for the registration. Here's my registration data with the references, the state, and the commands, which need to be separate for each of the alarms. So an array here of that registration data, and then the scene registration, deregistration, and a trigger alarm function, as well as 3 separate, because 3 is the max that I chose for now, alarms, 0, 1, and 2, that are to be overridden by the user. So we have the actual code for that. So I set everything in the array to start with, do the registration based on the ID to go to that slot in the array. The alarm, it just is a switch, and then it deletes all the commands when it's done. So the actual manager, again, has the big 4. It has an enum for alarm ID that I was using in the last class, actually. So this is where it's located. And then the static const alarm number just determines how many alarms there are. Obviously, if I changed this, I would also need to add more alarms up here, but they're right next to each other, so that shouldn't be too hard to remember in case you need to adjust this number. So default delete empty, register and deregister process elements, and then the various lists information. So it just goes through the whole list, checks whether or not it's under the total time, and then does those. And once it gets over that, it should break, and then doesn't need to check the rest. And as long as everything's inserted, like at the time, like in the appropriate order based on time, which it should be shown here, it won't need to, like, as long as they're in order, it shouldn't matter, is what I'm trying to get at. So next up is the inputable, the keyboard input, that is, along with its commands. So it has its own attorney again, has a map of events, and then a struct of registration data. And, oh yes, it also has a map of the key event managers, so that I do a lot of weird juggling of iterators here so that I can actually pass through the iterator to the registration data, so I can do the fast delete, but I did check and it does work. So I'll try to explain it as best as I can, but again, what I did was kind of weird, so hopefully it ends up making sense. So registration, deregistration is as simple as it can be. It just passes through the key, the event, and the iterator. Yes, it does pass through the iterator, by the way, because it needs that for the registration command, for reasons I will explain down here. So I go through to try and find the key. If I don't find it, I will insert, set the registration, deregistration, and state, as well as shown here. It sets the iterator, make sure it's deregistered, and then registers it, and then submits a command with the, it submits the registration command, that is. And when it comes down here to delete, it needs to find the proper pair. As long as it doesn't find it, it'll check that that's registered and deregister it. And then it submits the command that is stored there. And shown here, it just deletes all the registration and deregistration commands. So getting over to the keyboard and key event managers, which are in a separate folder, by the way, in case you have trouble finding them. So this is where all that stuff that I was trying to explain actually matters. So I have here the event list, the event iterator, the process events, register and deregister. So processes events, it just tells each of its key events, which we'll get to in a moment to do that. So the register, if it reaches the end, it sets a new key event manager and then inserts based on the passed in data, and then it sets the iterator. So this gets called regardless of whether or not the key is a newly created key or not. As long as it needs to be registered, it will do that. And then it deregisters here. So yeah, you can even see that I named this attorney part the input iterator fun, where I can finally get the iterator that I've painfully passed through and use that to quick deregister the inputable. And then here I just delete everything. And here we have the key event manager, which is just for an individual key. It has its own press list and release list, and it determines whether or not it was pressed last frame, as well as what it was pressed on the first frame. And the reason that there's a separate first frame check is because you don't want it so that if they had just pressed the button and you changed it to scene, for example, this is something that happened to me. If they pressed a button and that button press changes to scene, then the next scene will start by registering that button as still pressed, and you might change scene again, for example. So this just sets as true for the first frame, and then it always sets itself to false. So there's no if check or anything. So as far as I'm concerned, that should be fine. Switch statement for registration, switch statement for deregistration, just checking between press and release. And that's all that's really special about the key event manager. And that should be everything for the keyboard system. So now I'll go ahead and open up everything for collision. So first off is the collidable. Has its registration, deregistration, its attorney, big four, all of the same stuff. Has its own model as well as a beer sphere, specifically for the collision test calculations, which I'll get to in a moment. Reminds me I'll need to open the math tools, but I'll do that when I actually need to open the math tools. So I have more documentation for the set collidable group, select collision registration, deregistration, B-sphere, and the collider model, because those are the ones that actually, and the collision data, because those are the ones that the user's actually going to be using. So next up is the collidable.c++. Registration, deregistration, that's all the same pretty much. The actual group, on the other hand, determines everything of one type that needs to collide with everything of a certain other type, or with itself for that matter. So it has the default delete, empty, register and deregister, and then get collider collection, which just returns the collection. Really, this is just makes its own list of each type of object that needs to collide with things. So this is where things start to get complicated, because you can see that this is where the templates get involved, the collision with self and the collision with pair. It just makes the two collidable groups and then pushes them back into the commands. And when it comes time to actually process those, it just goes through each of the commands and executes them. And I will actually open these specific commands, because if I remember correctly, they are a little different than the regular commands. So I'll just open all of them and we'll go through. Yeah, the fact that they actually have C++ associated should tip you off that it's a big change. So it just has a big 4, the constructor and the execute. So the collision has self-command, essentially goes through each of the objects and checks it against everything past that point in the list. So that way you don't ever have to check something against itself or recheck something you've already checked. The pair command, on the other hand, it has to go through both lists every time because everything in one list needs to be checked with every single thing in another list. Base class is really nothing exciting, and the collision dispatch is also really not terribly interesting. It just does the static cast and then tells each of them to collide with the other. So that's everything for the collision, except the actual math check, which I'll show here. It's just a one class, or it's just a one function right now because we don't have any other ones, and it just takes 2 b-spheres. That does the check between the centers and then returns whether or not the distance was big enough to technically be colliding. So here I have the sprite class. It's just a class all by itself, and I just talked about this last week, but I'll talk about it again. So I have the big 4 here, along with an overridden constructor, because the base one we don't want to use. We want to use it with an image key. I have a whole lot of get and sets for pretty much all the variables that I have here. Center x, center y, position x, position y, scale x, scale y, and angle. So here's the actual sprite class. The constructor, it goes through, makes a model, shader, image. The model and shader are always the same, and then the image is based on the image key. It gets that image from the image manager, and then makes a sprite out of them. I have default sets for all of the various values, but again, you can go through and set all of these yourself, and each one, after you set it, it'll construct the world matrix and then set that as the world for the sprite. And this is, by the way, is how I'm calculating the world matrix. Scale, obviously, is scale x and scale y. The angle is just around the rotation c, because it's the only one that should rotate. And the translation, that is, it has the position minus the center. So that should correctly offset it, so the center is, in fact, in the center. And then this is just 0.0 as the default, because it shouldn't translate along with the z-axis. Sorry about that. It seems like this somehow got overwritten by the same code at some point, but if I'm understanding this correctly, the actual purpose of the function, what I do is I take the inputted pixels, find the total pixels of the sprite as it stands, and then divide that by that, which should give you what the new scale is supposed to be, and then I set that as the new scale. And then other than that, it just sets the matrix as normal. And then the render, it just gets the current orthographic camera and then renders to that camera. So I did not talk about the visualizer when I talked about everything else related to the collision, so I will now talk about that. So, big 4, type definition for the list, which is what I'm using, instance, the private delete, all the usual stuff. Come over here to the C++. So I make myself a unit sphere that the visualizer can use, along with the shader, and this is why having that shader and unisphere pre-declared is important, by the way. I actually don't have the shader manager pre-declared. I was actually debating doing that, but for some reason I don't remember why I didn't end up doing that, but so now that does need to be included in the load resources. Next up is shows the b-sphere. It just sets the size and position based on inputted values, calculates the matrix based on that, and then private renders using that matrix. And then visualize all just goes through, renders all of them, and then the delete is just a regular singleton delete. So we have here collection of vectors that I totally did not just make right now because I realized that we were supposed to have it. Right now it's only red, blue, and gray because those are the ones that I actually need to use, and those are the values for it. not really much to say on this one. So I guess I'll go ahead and show the actual demo now. It's going to take a bit to load, probably, so I might edit this out if it doesn't happen soon. Okay, that was surprisingly fast. I'll probably just leave that in. So this should be more or less the same. The only difference is plane's bigger, so you can still reach the edge, but you probably won't now. At least it's less likely. I notice I didn't actually show off collision, so I'll go ahead and run into this guy. Boom! I lose 3 life, but I also kill one of the tanks. Boom! And I also got shot, and I'll let him shoot me so that he can kill me that way. Oh no, I died. And then that just takes you to a blank screen. I will now re-debug and try to actually win this time. So yeah, colliding with the tank costs you 3. It destroys the enemy tank though. The bullets just cost 1. Because I needed something to happen when you collide with the tank, and that seemed like a logical enough thing to have. Bam, and bam. And if you didn't notice, I have life at the bottom too. So, and then winning also just takes you to a blue screen. Hypothetically, I could have made like a TGA that just said you win. If I had sprite fonts done, this is probably where I'd use them, but I don't right now. So for the time being, it's just a blue screen. Once I do sprite fonts, I'll probably go ahead and make this something a bit more fancy. But the actual gameplay should more or less hit all the beats that it's supposed to. I don't want to go through every single file with the game, because it's not really what the focus is supposed to be on, but I'll go ahead and look at some of the more important ones. So the enemy bullet, since those are the actual game objects. That's probably how I'll limit it, is I'll look at the game objects and then the scenes, and the managers and factories do about what you'd expect them to. So I update, draw, alarm, entry and exit, collision, along with setting parent to the manager, and all my private stuff. So I get the tank, I get the color red, use that to make my enemy tank, go through initialize, update the position. So I did some fancy math here to make it rotate in the right direction and target you. So yeah, that's the update function. No real follow up to that, and then the draw is much more simple. It's just a 1-line render. Alarm 0 just creates a bullet and then resets the alarm. Entry and exit just set the alarm, update, draw, and collision. No input for obvious reasons. The enemy delete just deletes its model. That's all it needs to delete. And the bullets, I'm just using a regular B-sphere for those right now, so no associated model, it just uses the B-sphere for the visualizer. Most of the same processes. The God camera is actually something that I did not talk about, and I'll probably go back in to look at. So it's a game object that you can drop into your game. Lots of stuff commented out here because I was still working it out. But it just gets the state of certain keys and determines what direction to move. And I will actually go ahead and launch again real quick and shoot that guy and shoot that guy so that hopefully I can buy myself some time. But there's the moving around, rotate, scale. And if I start moving, it just resets itself. So yeah, I ended up passing the scene. Actually, this is a new issue that I was having. I was not having when I first implemented this, so I might have to take a second look at that. But at the very least, the God cam is in there, kinda. I don't know what the problem seems to be, and I'm probably gonna need to relook at that. So next up is probably we'll look at the base scenes. The tank's actually I'll look at the tank because it has actual input. It's nothing exciting, but it gets the key pressed for shooting, gets the input. Where is the input? Oh, that's right. It's part of the scene. I'm dumb. But it actually has the input function. Well, there's all the movement, but it actually has the input function here. Just checks whether it's got the space bar hit down, and if it does, it'll shoot. And I also still have a debug thing left in there that I can easily change to the second scene, so that I don't have to go through the first 3 tanks every time if I don't want to. And since this is just for the sake of demoing off the properties of the game, I didn't necessarily see that as something that needed to be taken out, because there's no consumer who's gonna find that and say, oh no, I shouldn't be able to do that. So the base scene and the second base scene are the important ones. The lose scene, win scene are just empty pretty much. Initialize and end are the same. So separated out all of my includes nicely for the C++. Initialize, it just creates its plane, its 2 managers, and the God Cam, and then sets the target for the enemy factory, sets all the stuff for the enemy manager, has it spawn 3 tanks, and then sets all the collision pairs. And then when the scene ends, it deletes all that stuff and terminates the factory. So those do terminate on a scene-by-scene basis. And then scene 2 is more or less the same, just with 5 spawns in separate locations rather than just 3. So the final element to all this is various demos that I have. And I've shown most of these already, but I'll go ahead and demonstrate real quickly that I have started, and this is another thing that I will probably continue after I upload this video, is I've gone through and added comments to pretty much all the stuff based on what the focus of the demo is. So this one's focused on using resources, so I've commented what each of the load resources does, and then talk about, I've started and will continue to talk a little bit about the base scene, what that actually means, and how each of the boxes uses its own separate loading of textures based on what it's supposed to do. And it just shows off 3, when I get there, it shows off 2 boxes and 1 sprite. So, there we go. Sorry about that. It seems that I had my frigate mistitled. And I'm not actually using the frigate, I just wanted to demonstrate how to load a non-pre-made model. But yeah, regular 1, textured 1, sprite. That's all this demo does. And the others are unchanged from last time, but I can go ahead and give a brief overview of each of them real quick. So this one's just a scene change demo. Every time I hit enter, it takes me to a new scene, indicated by the cubes. So this also shows keyboard input, but mainly the change of scene. Yay. Next up should be the actual keyboard input demo that actually shows that in more detail. Hypothetically, I could have kept a part of the other demo, but this seemed more logical to do it in such a way that, so W key, S key, A, and D, so that way it shows more clearly the key that you are pressing is actually having an effect on the appropriate box. And last but not least, the alarm/collision demo. So this, you can't move or anything. All it does, it shoots, you turn red, and you turn blue again. Shoots, you turn red, you turn blue again. So the shooting is obviously on an alarm, and the turning red is obviously with the collision. So pretty simple, most similar to the game out of any of them, but even then, it hardly really qualifies as a game. So I will put these up separately rather than, I could comment them all out and try to shove them into the website, but it seems like it makes more sense to just actually include those as the actual solutions so that you can run them if you want to. So that, looking through the checklist, I think I've covered everything. I don't feel like I've missed anything. So at the very least, everything should be in there. The only thing from the sprints I did not do was the sprite fonts, which I know is bad, but it's not the hugest part of the assignment. And like I said, I am planning to finish that when I have more time over break. So this should be everything for Engine 1. I guess we'll continue next time.